Okay, in this topic we'll be learning about factoring trinomials of the form ax squared plus bx plus c. Here, if you notice, there is a value other than 1 in front of the x squared. We'll be talking of trinomials such as 2x squared plus 5x plus 3, and another example is 6a squared minus 17a plus 5. We will be talking of two trinomials like that as examples so that we can see how this works. So how do we factor it out? There are two methods that are used to factor these trinomials. Two methods, okay? With the first method, educated guesses are made. So remember, we'll be depending on guess if we are looking at that particular method. These guesses are checked by multiplication, as you will see in a little while. The correct factorization is determined by the process of elimination. All right. If we are using the guess method, then it's by the process of elimination that you're going to be trying it out. So that means that you may try 1, 2, 3, 4, 5, many different methods. Many different numbers, and then that means you may get to the answer it may be, or it may not be, and it may take a long period of time depending on how well you choose the numbers, or how more acceptable values it actually has, or the size of the numbers that we're talking about. The second method is an extension of factoring by groups, by grouping, which we have done in the previous videos. Okay, so let's start with this one here, that we are going to be factor trinomials, okay, using the trial and check method. So that means that you will be trying many values to solve this one here. So let's go a little bit more. I will be using the same two examples that I presented so that we can work with. So when I look at this value of this trinomial, let me write it here, and I have 2x squared plus 5x plus 3. Let us work this out and see what is our solution. So when I get this and I multiply this out, or when I factor this out, I will get a particular value. All right, so what we are going to do is that we will be looking at the factored method, and then we're going to see how it unveils itself to get to this endpoint. So if we were to factor this out, this is what would have happened as a solution. We would end up with 2x plus 3, open close bracket, and then open the second bracket, x plus 1. Okay, now how this works is as follows. Consider that you've been given only this. All right, so let's see how this goes from here to here, and how this goes from here to here, and then we're going to see the check and trial method, how that works. So when we multiply this out, I want you to note carefully. We usually say 2x times x, so that gives us 2x squared, and then 2x times 1, which gives us 2x, and then we say 3 times x, which is 3x, and then 3 times 1, which is then 3. When we combine them, we end up with 2x squared plus 5x plus 3. Notice what just happened. We just went from here to here, which is this starting trinomial here. Now note carefully, all right, and I want you to notice this 2x here, okay, this 2x times this x here gave us 2x squared, which is the first term. Okay, and then if you notice, this 3 times this 1 gave us this 3, or this value here at the end. So what can we observe here? We can observe that the first two terms being multiplied will give us the first term in the trinomial. The last two terms multiplied will give us the last term in the trinomial. All right, but what about the middle term? Well, if you notice now that the first two terms we said we end up with 2x squared, and the last two terms will give us a 3x. Notice that the middle term now are different from 5 from 5 from the 5x here. We got 2x and 3x. But what can we say about the 5x? It is the sum of the two middle terms. Okay, so this value here is the sum of these two middle terms here. Okay, so now let's try the next one and see what then happens. Consider that I give it the next one. I'm going to give it the next one in this form, and we go to this method. So consider that we have now 2x plus 1 and x plus 3. Notice I'm just moving the 3 from its position. When you multiply this out, we end up with 2x squared plus 6x plus x plus 3. When you combine it, we end up with 2x squared plus 7x plus 3. Notice 2x times 3, 6x. So let me do the marking. 2x times x, 2x times 3, 6x. 1 times x, and 1 times 3, 3. Okay, now notice carefully again. The first two terms multiplied give us the 2x squared. Okay, these first two terms here, when we multiply them, we end up with the first term here. Let me zoom in that a little bit more so you can see it much better. So if you notice here, when you multiply these two terms, you end up with this. When you multiply the 1 and the 3, we end up with this last term. What do we notice? The middle term are different, right? In this case, notice here they're different compared, despite they might look almost alike with the previous one. So then let's proceed. Zoom back again. So there we have our problem. Now in each case the result is a trinomial. Notice if we start from here, we end up with a trinomial. So key observations, and I want you to note this. The key observations are the first terms are the same. In this case we call it 2x squared. I'm not saying that everyone will have 2x squared. I'm just saying that no matter what, whenever we have them in brackets, the first term will be the first two terms being multiplied. The last term are the same, which gives us 3. And finally the middle terms are different. So not because you have the first term and the last term the same means the middle term will be the same. No, it doesn't work that way. It's simply telling you that something is different with respect to middle term. So from this observation indicate that when the last terms in this case here, we have this one here, are interchanged to this one here to form this new factored form, the only middle terms of the products are different. So despite we change them from here, notice that we put the 3, we combine with the 2x and the one outside, then the only difference is a middle value, right? Nothing else. This fact helps us in when factoring trinomials using the trial and check method, which we will be doing right now. Just trial and check, so we will just be checking them. So let's start with some few examples now. Examples, I believe I will be labeling them example 1, example 2. Example 1 of this method. Okay, so I'm going to be factoring out, I gave you 2x squared plus 5x plus 3. We will assume that this trinomial is the product of two binomials, and we will say that we will use a systematic method to find their terms. Okay, that's the key point. That's our strategy, because we know should be the product of two binomials. Why? Since 2x squared plus 5x do not have a common factor other than 1, then the only option available is to try to factor it as the product of two binomials, because if they had like a value that can be divided by a common term all across except 1, then we factor that out first. Solution now. Since the first term 2x squared, the first term of the binomial factors must be 2x and 2x. We know that for a fact, because remember we said that when we have our brackets here, we know that the only way you can get this first term is that if you multiply two values, which will give us 2x squared, which will be 2x times x. Those are the only two combinations that can give us 2x squared. And then, right, to fill in the blank here now, which is empty, we must find two factors of 3. Right? What are the factors of 3? The only way how you could get 3 is to say 1 times 3 or 3 times 1, and we'll give a middle term of 5x. So how can we get 5x as the middle term as a sum? But when we multiply with the 2x, okay? So because 2x times x will give 2x squared, and then because each of the terms of the trinomials is positive, we need only consider positive factors on the last term. All right, meaning then that the only way how we can get 3 being positive is that if we multiply two positive values in this case, or two negatives. But since all of them are positive, then you don't have to worry about negative values. That means that the two numbers must be positive, either 3, positive 3 here, or and positive 1, or positive 1 and positive 3. Okay, now since we have this, we can say that the possible solutions could be that we put plus 3 here, plus 1 here, or we can say 2x plus 1 times x plus 3. Those are the only two possible ways. When we are not saying that these are the two solutions, we're saying these are the two possible ways. So the first possibility is incorrect. Okay, I mean, no, this possibility here is the correct one, and this is the incorrect one. Let's see why. If I take, let's use this first one as example. So I'm going to bring this one here and see what then happens. I have 2x plus 1 and x plus 3. If I expand this out, I would say 2x times x, which gives me 2x. Okay, it looks promising. And then 2x times 3, that gives me 6x. That doesn't look good now because we've already passed the 5x, so we could stop at that point. But nevertheless, let's see what this would then give us. 1 times x, that would give us x, and 1 times 3, that would give us 3, which would then be 2x squared plus 7x plus 3. So this combination is not the correct one. I'm not saying that this is the correct one either. Let's see now if this will work. So if we have 2x plus 3 now and x plus 1, when we multiply this out, we end up with 2x squared, 2x times x, 2x squared, 2x times 1 gives me 2x, 3 times x gives me 3x, and 3 times 1 will give me 3. This gives me a solution of 2x squared plus 5x plus 3. This is the correct one. This is the correct choice. Right, now notice this is the trial and check method. Okay, so it might be challenging because you have to try it out. You cannot just guess a number and say that's the correct one. But if you notice, there's a way you could work this out. You simply say this times this and this times this. 3x, 2x, 5x. If you say here x plus 6 plus 6x, 7x, so that's not correct. So that's the trial and check method. All right, so let's go over this again. The outer, if you notice, we have 2x times x will give us 2x. 3 times 1 will give us 3. So that is okay. I mean 2x squared, and that gives us 3. So the outer ones are correct. Here we say 2x squared again and 3, so that's okay. So we're okay with the outer ones. Now the problem is the inner one. So let's see what then happens. multiply these two, we have x and 6x, that's 7x. We don't need that. But if you notice here, we say 3 times x and 2x times 1, that gives us 3x and 2x, 5x. So this is the correct method. So that's the trial and check method. You could do it very fast. How? Just notice, okay, I will choose my first two terms because I can get this first term here, and then I guess I have two numbers which will give me the n value. So now I must find the how we say, the factors which will give me this n value, and that will go for the middle term. But you just have to know how to combine them. Okay, that is the challenge part on this problem. Let's go with our next one. That was example 1. We're going to example 2 now. Example 2. We have 6a squared minus 17a plus 5. We will assume that this polynomial is the product of two binomials at all times to start with, and we will use a systematic method to find their terms, which we will. Why? Since the terms of the trinomials do not have a common factor other than 1, the only option available is to try factor it out as a product of two binomials. The solution to this problem here will be, since the first term is 6a squared, the first terms of the binomial factors must be 6a and a, or 3a and a. So here's where a next more challenge coming with the trial and check method. The first term, remember, this is the trial and check method. You don't have to do this method here, but you need to learn this. Okay, so 6a squared could come from 6a times 1, no, times a, or it can come from 3a times 2a. So now the possibilities is increasing just for the first term. Okay, now to fill in the blanks, because we now have a possibility of having more solutions, you can have here 6a and a, 3a and 2a. You can have those possibilities. To fill in the blanks here, if you notice, we must find two factors of 5. What two factors can give us 5? But the only way how we can get 5 if we multiply them is to say 5 times 1. Alright? So we can use that. But if you notice, the middle term is a negative. So we need, the only way how we can multiply two terms is that if we multiply them, we get a positive value. And the only way how we can get two negatives to multiply to become positive is that if the two negatives are, if the values are both negatives. That's the only way. So the only way we could get this is that if we say -1 times -5, or -5 and -1. Those are the only possible ways. So this is all. So let's trial and see which one gives us the correct value. 6a times a will give me 6a squared. 6a times -5 will give me -30a. -1 times a, -a. -1 times -5 will give me +5. This gives me a 6a squared minus 31a plus 5. So this is not the correct combination. So that won't work. Let's try this next one. 3a times 2a, 6a squared. 3a times -1, -3a. -5 times +2a times +2a, -10a. -5 times -1, +5. Notice now, 6a squared minus 10, 6. Oh, sorry, this would have been 2a and 1 and 1, 5a. So we end up here with -13a plus 5. So notice this is what we got here. So therefore, let's try a next one, because those may not work as combination. Remember, we said 6a minus 1, and then we said 3a minus 5. But this could be also a different combination. We can put the 5 and the 1 opposite. So let's try that. So we can have 6a minus 5 and a minus 1, or we can have 3a minus 1 and 2a minus 5. That is a possible combination. Remember, this is trial and check method, so therefore we'll try and check which one would work. So therefore, let's try this other combination. 6a times a gives me 6a squared. 6a times negative 1, negative 6a. 5 times a, negative 5a. Negative 5 times negative 1, positive 5. 6a squared minus 11a plus 5. So again, this is not the proper combination. Let's try the next one. We have 3a times 2a, that is going to give me 6a squared. 3a times negative 5, negative 15a. Negative 1 times 2a, negative 2a. Negative 1 times negative 5, positive 5. Here gives us 6a squared minus 17a plus 5. This is the correct combination, because this is what we want for our solution. Okay, so this is the two binomials that we're looking for. Now notice the trial and check method, how much we have had to do, but if you choose the values much faster, then it can become much easier to calculate it. All right, so this is where the challenge comes in for this one here. Let's try a next one. Example 3. Okay, so here we're gonna have example 3. 3y squared minus 7y minus 6. So we know for sure that for us to get the first term, we can simply say 3y times y. We know it for a fact. However, the last term, the only way we can get a negative 6 is that if we multiply a positive and a negative. That's the only way how we get a positive negative 6y. However, this is a trial and check method. The possibility of getting a 6 is that we multiply a positive 6 and negative 1, or a 3 and 2. So depending which one you want us to try. Let's try with the simplest values. So we'll try 1 and 6. That will give us both positive, will give us a negative 6. That's not going to work, so it could be a negative 1 and a positive 6, or a positive 1 and a negative 6. So we're going to try these values to multiply to get us the last value and then the middle term. So let's see if this works. If we put a negative 1 here plus 6 here, when we multiply this out, we end up with 3y, and these two terms here, negative 6. So we get the 3y squared and the negative 6, so that looks promising. But when we multiply these two, this times this and this times this is what we need for the middle term. Remember, for the middle term is a combination of the last terms to multiply and two inner terms. So here we would end up with a negative y, and next one would be 18y. 18y minus y is going to give us 17y. So it gives us positive 17y. That's not what we need, so that's not the accepted value. So we go for our next combination. 3y and y, and instead of having negative 1, we're going to say positive 1, positive 6. We know that with the end values are going to be okay, so we can write them down. You can say now this will give us 18y, and this is going to give us y, or negative 18y. Sorry about that, this is supposed to be negative. Remember, we're just changing their signs. The negative 18y, and that then gives us negative 17y. Again, this is not the correct combination, so we try the next one. Remember, this is a trial and check method. Trial and check is a time consuming, but we need to understand its concept. So when we multiply this out, we're going to use now values of 2 and 3, which can be 2 and 3, negative, positive, positive, negative. So we put here plus 2 negative 3. The first two terms will give us 3y squared, that's okay, and negative 6, that is okay. So we're okay with this piece here. Now the middle terms, 2y, negative 9y. So negative 9y plus 2y will give us 3y squared, negative 7y minus 6. So this is the correct combination. Alright, and if you had tried negative 2 positive 3, it would not give us a negative 7. Okay, let's just try it for us to see if it's true. So 3y positive 3y negative 2, this would give us 3y negative 6y. Okay, so we end up with 3y squared for sure, negative 6, negative 6y plus 3y, that will give us 3y squared, negative 3y minus 6. So that would not work. Okay, so this is not the combination, this is the correct combination. So our solution for this problem here would then be 3y plus 3y minus 2. That would be our correct combination for being factorial. Now remember, this is a trial and check method. It's time consuming, but we need to understand what's the concept behind it. Alright, let's do another example on trial and check method and see how that works out. So we have a next example. What's example 3? This is example 4. We have 4b squared plus 8bc minus 45c squared. Our strategy here is that we will assume that this trinomial is a product of two binomials, and we will assume that a systematic method can be used to find the solution. Why? Since the terms of this trinomial do not have a common factor other than 1, the only option available is to try the factor it as a product of two binomials. Alright, since the first term is 4b squared, the first term of the factors must be 4b and b, or 2b times 2b. Alright, so that increases the possibilities. Notice, the only way how we can get this 4b is that if we say 4b times b, or 2b times 2b. That's the only way how we could get 4b squared. Right? To fill in the blanks here, we must find two factors of negative 45c squared that will give a middle term of 8bc. Since negative 45c squared has many factors, and we already know that we're looking at 1, 3, 5, 9, 15 and 45. Okay, with many factors, there are many possible combinations for the last terms, right? This last term here, okay, of the binomial factors. The signs of the factors must be different for sure, because we need a negative 45. There's no way we can multiply two negatives and get a negative, or two positive and we get a negative. So one of them has to be positive and one of them has to be negative. If we pick factors of 4b and b for the first two terms, and negative c and 45 for the last two terms, the multiplication gives an incorrect term of 179bc. Let's see. Negative c, let me use blue for this one here, negative c and negative 45c. When we multiply it out, the middle term becomes here 4 times 45, that gives us 120, 16, 18. Okay, that is going to give us 45. We have 4b and b, and the first two terms negative c and positive, positive 45. So that's 20, 16, 18. And then when we multiply this, so we'll get negative bc. This would be 45 bc. So our last value when we add these two terms would give us positive 179 bc. So that's far away from this. So we go to the next one. If we pick factors of 4b and b now, right, 4b and b, and for the first two terms, and 15c and negative 3c, because that will also work for 45. So we can say now 4b, and we say b here, and let's say we choose factors of 45, negative 45 to be positive, say 15c and negative 3c. Remember, you have tried many factors. Just consider that you have tried all of the possible values and you should to this one here, because in this one here you could probably take a whole page and 2 pages to do all the working. So I'm going straight to some values so you can see what then happens. When we multiply this out, we end up with that is okay. We multiply the two last ones. That is going to give us negative 12bc, and this 2 is going to give us 15bc. 15bc take away 12bc is going to give us 3bc. So that's not the correct combination. Now if we pick factors of 2b and 2b now, this combination, let's see what then happens. And for the first two terms, and negative 5c and positive 9c for the last two terms. Remember, we're just guessing terms. This is trial and check method, because this 2 will give us negative 45. This is what happens. These two terms multiply, give us 18bc. These two terms give us negative 10bc. 18bc take away 10bc will give us the 8bc which we want. And we already know that this 2b times 2b is going to give us 4b squared, and we know that negative 5c times 9c will give us negative 45c squared. So when we did this combination, we end up with 18c, now 18bc minus 10bc. This gives us 4b squared plus 4b plus 18bc minus 45c squared. So that's the correct combination, right? Because that's what we want. So this is a binomial that we need for this particular problem. Okay, so that's the binomial by trial and check method. Okay, it's time consuming, but we need to understand this concept that you may try many methods. So once you've understood this, we can go to the next video and see factoring trinomials after factoring out the GCF.